Hey, this is Don from Padlock Technologies again with another question about private VLANing. What's the point of it? Why would you use it? What are some of the components? And from a design perspective, where does it fit into your design? So, private VLANs is a security concept. If you know anything about like ACI or microsegmentation, stuff like that, it kind of fits in that vein. But it has only about three really moving parts here. There's the promiscuous port. I'm just going to say pro port because I don't feel like spelling promiscuous. There is the isolated VLAN, and then there's the community VLAN, right? And depending on what you configured on the port, either machines can talk to each other or they can't talk to each other. And what does that mean? So let's say we have a switch here, all right? And then I'm going to have the uplink here go into the router, right? Let's say this is a router or firewall, whatever you want to call it. So this port here is your pro port. Now, doesn't have to actually be a port itself. It could be a VLAN, it could be the promiscuous VLAN, the whole nine, right? What the point of the pro port or pro VLAN is to allow, outside access, right? Outside access. Now, the isolated VLAN, let's say you have some workloads down here. All right, workloads, and they're all going to the switch. So I'm going to use green for isolated. All right, so isolated VLANs here and here. And then community VLAN is here. All right, these are in the community VLAN. Now they're all in the same subnet of 192.168.10/24. So because they're in the same layer 2 segment or layer 2 domain, you would think, hey, these can talk freely because technically you're on the same level too. All right, and there's no SGT, there's none of that. Now the key here with private VLANing is these isolated ports are basically saying, hey, you can only talk to the promiscuous port, and that is it. So even though these two are in the same switch, same layer 2 domain, they cannot talk to each other, thus isolated. They're isolated from everybody on the network. The community VLAN says you can talk to the promiscuous port or promiscuous VLAN and anybody in the same community VLAN community, right? So they can talk to each other, but they cannot talk to anything that's in the isolated world. And the isolated world can't talk to anything in the community VLAN. Now, why? That's the whole purpose of private VLANs. Now, why would you do it? Well, very simple. You want to reduce your attack surface. So let's say a bad guy up here, he gets through your firewall for some reason, and this workload is attacked. So that workload is attacked. Well, this workload can only talk back outside. It can't talk to these resources down here. So the whole purpose of this is to avoid lateral movement, right? So if I attack this machine here, I cannot move on to this machine. I can't move laterally to the next isolated VLAN or isolated port or isolated workload, and I can't talk to community workloads. So this was like pre-micro segmentation, before the word micro segmentation became like what it is. This is how you would avoid people in the same layer 2 domain talking to each other. Now, you can do things like TrustSec with ICE to do the same thing that private VLANing would do, right? In ACI, you have this, you have a micro seg EPG kind of does the same thing. And then you would have your contract that applies to the microseg EPG that's in the same technical overarching EPG. So same concept, just in different, they implement it differently. If you're using ICE, you're using, let me put ICE, you're going to use TrustSec. If you're going to use ACI, you're going to use, EPGs, micro EPGs, contracts, stuff like that. So that is the entire purpose of private VLANing. This is just what it is, what it was used for, where you would see this. You would kind of see this off the firewall in like a DMZ switch. So this would be, let me already use blue. This would be a DMZ switch here, right? And then you would just allow that traffic to go down to from the promiscuous port, and then these workloads, 1, 2, 3, and 4, they can talk to the outside world perfectly fine. But if one was compromised in the isolated VLAN, then they can't talk to each other, right? Now, the next question is, why wouldn't you just make everything isolated, everything in the isolated VLAN? Well, the problem with that is if these two machines need to talk to each other for some reason, case in point, say this is the front end web server, right? The web GUI that people talk to. And then this right here is the backend database, right? That they talk to. Well, if you put these two in an isolated VLAN, this communication can no longer happen, thus breaking the application. So you have to be very cautious about what you want to do, right? This is a design question that you got to ask yourself, because technically if workload number 3 gets compromised, you can technically compromise number 4 because those two can talk to each other. If you put them in an isolated VLAN though, they'll never talk to each other and you break the application. This is where certain things like TrustSec can kind of help you with this, because then you can assign, if I was going to do TrustSec, you can assign SGT value 1, SGT value 2, and then you have your policy that limits what they can talk to each other for. And then you really don't have to worry about doing this whole private VLAN and nonsense that, used to do back in the day. Now there's still use cases for it, but it's a lot more convoluted than doing something like TrustSec or microseg with ACI. So that was a brief description of, private VLANs, why you would use it. What is the point? What are some of the components that are involved in using private VLAN concept? Hopefully this video was informative. Thank you and have a nice day.